All right, lesson 1.3. We've made it through 2 lessons so far, so I hope you guys are doing okay and you're sticking with me. We're going to talk about distance and midpoint today, and these are going to be formulas that you're going to want to be able to recall and use. So the distance formula especially, we're going to want to be able to memorize that when we're finished. Okay, so the first thing we want to do is we want to find the slope. And remember that slope is rise over run. That would be review from algebra. And when they ask for length, length is really just distance. So let's start with slope. Slope is rise over run, like we wrote down before, or some people say change in y over change in x. The little triangle is actually the Greek letter delta, and it means change. Or sometimes people use the equation y2 minus y1 over x2 minus x1, which is really the same thing as the change in y, the difference in y over the change in x, or the difference in x. So let's write the coordinates of our 2 points here. Point A is at 2, 1. Point B is at 6, 4. And change in y over change in x, we could count that. I'm going to show you in just a second, but I want to do the formula first. So this is your first x and your first y and your second x and your second y. So y2 minus y1. So here was y2, here was y1, over, oops, let's change back to the pen, over x2 minus x1. Here is x2, here is x1. So that gives us a slope of 4 minus 1, which is 3, 6 minus 2, which is 4. So that should be our slope. Now we also could have drawn this line in, and we could have said the rise is 3, the run is 4, rise over run. The reason we want to be able to do it from coordinates is because sometimes we aren't given the graph, sometimes we are only given the coordinates, and we need to be able to use the formula without having to graph it. Now the distance formula. Distance equals parentheses x2 minus x1 squared plus y2 minus y1 squared. So this is the distance formula. So let's take what we have and plug it into this. x2 is 6 minus x1 is 2 squared plus y2 is 4 minus y1 squared. Now I usually just put it in my calculator from here using the square root and the parentheses and the squared, everything exactly like you see it. But I'm going to go ahead and work this one out by hand just so you can see what happens. 6 minus 2 is 4 squared. 4 minus 1 is 3 squared. So that is the square root of 16 plus the square root of 9, which is the square root of 25, which equals 5. So this distance right here that I just highlighted has a length of 5. So that brings us to the distance formula. Now this says prove the distance formula. I actually want you to cross that out, and I want you to write the word derive. Derive means get to the distance formula by starting at something else. What we do know about is we know the Pythagorean theorem. That is something that is a review from previous years. C squared equals A squared plus B squared. So that's where we're going to start with our derivation of the distance formula. So we're going to use this graph over here, and I know it doesn't have any numbers on it. We are going to go ahead and mark these. I'm going to blow this up a little bit so you can see. We're going to say that this is x1, y1, which makes, this is still y, this point right here is still y1 because it's still on the same y, but this is going to be x2, y1. And that's going to make this x2, y2. And this is going to be your A side, this is going to be your B side, this is going to be your C side. And we know that AB, capital A, oh dear, times capital B equals capital C, which, by the way, this point down here was C. So this is given information right here. Given information. This is what we're going to start with. So now we're going to take some pictures that we have, or some information that we have from our picture. We know that little a, this side right here, if we want the distance of that, we would take this point, which is x2, minus this point, which is x1. That would be the distance between that. And if we wanted to find B, so here's B right here, we would want to take this point on the y minus this point on the y. So B would equal y2 minus y1. And if AB equals C, if A times B equals C, then we're going to say that A squared, well, let's call it AB squared, equals x squared, or x2 minus x1 squared plus y2 minus y1 squared.